We got a hot take on SMPTE ST2110. Every time we talk to a room full of TV engineers, you hear the same thing over and over. Adopting 2110 is way too expensive. Well, okay, what if it's not? Before I go any further, a quick word of caution. I just want to point out that there are many scenarios when a live production may want to go all in on NDI, 12 gig, with an extra upgrade investment. Application, cost, workflow, and hundreds of other factors play into this decision making. But hear me out. I'll break down the math and the factors that help determine whether transitioning to 2110 makes sense. Let's get the obvious stuff out of the way. I work for a systems integrator, Keycode Media, but have been in the industry at Grass Valley, Imagine Communications, and others for many years before that. The fun thing about being at an integrator is you get to see the big picture. The products, how they work, or in some cases, how they don't work. I also see how facilities design, connectivity, labor, training, all the way down to support contracts factor into the cost of building a greenfield new TV station or upgrading over phases year after year. I've spent the last several months helping a major TV station do its first rebuild in 13 years at a new location. 3 full studios, do-it-yourself set, multi-format streaming, and 8 edit bays. They need to go from 720p to 1080p with the ability to do HDR as well. All of this at launch and 4K in the future. During the discovery phase for this project, we evaluated whether to go 12 gig, 3 gig, or SMPTE 2110, or a combination of the three. We spent countless hours analyzing camera systems, multi-viewers, video switchers, graphics, gateways, and orchestration products, etc. Our engineers looked at cable runs for 12 gig, 3 gig, and SMPTE 2110. We also looked at the service hours it would take to integrate, test, and commission the equipment and to train the local staff. Throughout all of our analysis, we took into consideration a 7 to 10 year lifespan for the new facility. What we found was the total cost of ownership for a full SMPTE 2110 facility was not just cheaper than 12 gig, but it was cheaper than building a 3 gig facility today. Wait, what? The cost savings really comes down to 4 of the key features that come with transitioning to IP versus traditional SDI. That is, simplification of signal routing, the reduction of physical cabling of the facility, the utilization of COTS hardware riding the IP network curve, plus the cost of fiber has come way down. Now you might be thinking, a lot of the SMPTE versions of products would have a higher sticker price. Say a SMPTE ST2110 PTZ camera might be $10,000. Yet a similar PTZ camera without 2110 might run around $5,000. How is a $5,000 difference or more expensive camera going to save me money in the long run? If you look at any one product in the 2110 workflow, it likely might be more expensive. But you have to start thinking of what capabilities you get from having that signal no longer be SDI based. You have to say, what money will I save when I no longer need as many unique signal paths and can simply use Multicast to get any video signal at any time to any compatible device or process on the network. More on Multicast in a bit. Cable lengths can add up when you need separate cables for video, audio, metadata, and control. IP-based infrastructure can help you consolidate that rat's nest of cables in your studio, replacing much of the infrastructure with a single fiber cable per device to a centralized network. We found that 2110 builds can be more affordable than baseband 12 gig or 3 gig in key areas. Core routing and infrastructure. This is because your router is no longer limited by the crosspoint capability of an SDI router, and you can leverage the incredible scalability of an IP network routing infrastructure. Conversion and processing. You no longer need dedicated crosspoints on the router to loop in conversion and processing. You simply use Multicast to get what you need to the desired processes. Multiviewers. Everyone wants to see the screens in the production room these days. This has caused the demand for the multi-view feeds to explode. Each of those takes a crosspoint on the traditional router and unique processing heads. With Multicast and COTS hardware, you're significantly reducing that cost as well as adding scalability and expandability to the multi-viewer system. Audio. While audio has been in the digital IP network domain for years, SMPTE 2110 enables us to keep audio in band and in time with the video signals, reducing the cost of additional processing elements in the signal chain. Lastly, cable infrastructure and the install and integration services costs drop dramatically as well. In greenfield installs, it is cheaper and easier to pull large numbers of fibers than it is to pull multiple strands of 1694A coax or other signal cable types. Let's go a little deeper into Multicast. In its simplest form, Multicast allows you to send from one source to multiple receivers and receiver types without the need for an increasing number of SDI router crosspoints. Traditionally, with UDP-based SDI, you would need to physically create a unique switchable physical signal path to each subscribing device along with its return path, consuming a large number of SDI router crosspoints. This often results in the facility running out of router space and facing not just a doubling cost to expand, but often a 4x cost. Those days are gone with 2110 and IP-based systems. A video signal is only transmitted once, the source, and it's automatically replicated by the IP network infrastructure to each subscriber. It's the difference between IP networks' virtual crosspoints and the physical crosspoints needed for UDP signals. Now I want to go back to my original words of caution. It's kind of an interesting dilemma. Most facilities do not do a wholesale upgrade, greenfield installation like what we're doing with this current television station. In most cases, facilities are only upgrading part of their workflow at any time. In our analysis, we found that if a facility is looking to upgrade at least 30% of their infrastructure to 2110, you're going to pay 40 to 50% more for the solution than if it was only a 12 gig or 3 gig upgrade. Short-term, 2110 is more expensive upfront in this scenario. However, when you get to that 60 to 70% range of converting to a new 2110 infrastructure solution, you hit a break-even point. Often the 2110 solution ends up being equal to or less than a baseband infrastructure. While I get that most of you are not likely upgrading 60 to 70% of your infrastructure to 2110 at this exact moment, it may make you think, how many upgrades until I get to 60 or 70% 2110 capable? Would it be 2 to 3 upgrades, 1 year, 5 years, 10 years? That's your break-even point. Knowing at some point 2110 is going to make financial sense. As ST2110 products come down in price and the adoption increases, we're going to see that breakover point continue to come down over the next few years. Maybe in a few years, it will be only 20% or less that you'll be paying more. Ultimately, making the switch to IP will make sense, as you will be able to ride the IT cost curve on signal infrastructure that you cannot get with SDI. All right. So hopefully that was a decent overview of SMPTE 2110 and the trends we're seeing with IP installations. What has been your experience with 2110, IP or baseband infrastructure design of late? Do you agree, disagree? Send us your questions and comments and we'll get back to you.